Hi, here we are for section 7.2, confidence intervals for the mean. So a confidence interval for the mean would look something like this, that the average is between 80 and 84. So that sounds like maybe the average temperature in Maui. Would it be nice to be in Maui right now? Well, anyway, with this interval, notice that 82 would be right in the middle. So that means somebody found that the sample mean is 82. Then it could be off by plus or minus 2. So they added 2 to get 84, they subtracted 2 to get 80, so the error must have been 2 degrees. And the goal for us is to find out how do you get this 2 degrees, or how do you get the error. So you'll be given sample information, x bar, s, and n, and with that we create a whole new parameter which is called t. Well, it's not really that new. It's basically just the z formula, except down here is only the sample standard deviation is known. So it's very similar. The picture looks the same, like a bell-shaped curve, but we can't use the z distribution, or in other words, we can't use table A2 because the numbers are slightly different for the t distribution. That's right. The good news is we get to use a whole new table. So this table is called A3, and it looks like this. It's actually easier to use than table A2. It's just this one page right here. You'll notice over here on the left is degrees of freedom. Well, the formula for degrees of freedom is very easy. It's just n minus 1, so sample size minus 1. And then you would look down, find the degrees of freedom, and then you only have to decide which column to use. Notice right here it says 2 tails or 1 tail. Well, confidence intervals always have 2 tails, so here in chapter 7 we'll only be using this part, 2 tails. Later in chapter 8 we could use 1 tail, but for now it's 2 tails. And then how do you decide which column to use? Let's look at an example. So use table A3. Suppose the sample size is 43, and we're using 95% level of confidence. Here's the table. Degrees of freedom is just 43 minus 1, so that's 42. And I chose that number specifically because there are going to be times you're looking through this, trying to find 42, and you get down here, and there's the choice of 40 or 45. Whenever these tables don't have what you're looking for, just use whatever's closest. Doesn't matter if it's over or under, just use whatever's closest. So in this case, I would use a 40. The next thing is which column to use. So if we're using 95% level of confidence, and you do 1 minus that, it gives you 0.05. And this is called alpha, so alpha equals 0.05. So that means we'd be using this middle column right here. So go down the middle column like the line shows, and then we're using degrees of freedom is 40, and so those two meet right down here at 2.021. So t sub alpha over 2, also sometimes called the critical value, is 2.021. Now let's put the whole thing together. So the formula is going to be take the x bar, add the error on one side, take the x bar, subtract the error on the other side. Sort of like I did with the temperature of Maui, take 82 plus 2, 82 minus 2, that's where the confidence interval comes from. But how do you find the error? Good question. So if you look at this little formula, it's just take the critical value, like the 2.021, put that right here, and then the standard deviation divided by the square root of n. And that's it. Bob's your uncle. So let's do an example. 37 Hartnell College students were asked how many hours they work. The average, 16.07. Standard deviation, 14.18. Now we're going to create the 98% confidence interval for the average number of hours that they work. So first of all, it's a good idea to write down the sample information. Since n is equal to 37, that means degrees of freedom is 36. And we're using 98% confidence level, So if you do 1 minus 0.98, you'll get alpha equals 0.02. And now, where did I put that table? Oh, here it is. Table A3. So we're going to be using 0.02, so go down this column right here. And then degrees of freedom is 36, so go across this row right here. And the critical value is 2.434. Next up, do a little bit of math. So using that formula that I just mentioned, here is the critical value, or t sub alpha over 2. Then this is standard deviation divided by the square root of n. Pop that into a calculator, and it says the error 5.674. So in other words, hey, where'd you go? There you are. So in other words, people work an average of 16.07 hours, plus or minus the 5.674. So you add the error on the right side, subtract it on the left side, and then there it is. So that's saying, based on these 37 people, I'm estimating that at Hartnell, students work somewhere between the 10.396 and 21.744. And as long as those 37 people were chosen randomly, I can be 98% confident that this interval does truly represent Hartnell College. All right, so that was using the formula, which was a lot of fun. But you can actually do this on the graphing calculator as well. In fact, on tests and quizzes, final as well, then I would expect that you are using the TI-84. So it would look like this. You go to Stat, move over to Tests, go down to where it says T interval. Then you type in the given data. So by the way, right here, make sure that this is saying stats, so you can type in X bar, S, and the N. If you had a list of data, that's when you would click on data. So that would be if you went and typed in a bunch of numbers into list 1, you wanted to use that, that's when you would use data. Anyway, tell it what the confidence level is, go down to calculate, and ta-da, there's the answer. Now you'll notice that these numbers are just slightly different than what I got. They're actually slightly more accurate. So using the calculator is not only faster, easier, more fun, but it's also more accurate.